Well, hello there. Sion Batson here from Sion Batson Tutoring, and in this video, we will be talking about terms, like terms, and identifying like terms. Very important concept for all of my 6th graders, 7th graders, and even if you are getting ready to take the GED exam, this video is for you. So, join me. Now, this exercise is out of my 7th grade math workbook. You can master 7th grade math, next generation learning standards. This workbook covers all of the next generation learning standards as well as all of the Common Core learning standards for 7th grade. This workbook is filled with very simple and easy to follow notes, step-by-step examples, guided examples, and more than 1100 practice problems and answers. Parents love this workbook. Students love this workbook, and the teachers love this workbook because it's a great resource for extra practice at home, for homework help, and it is also the ultimate study guide to help your scholars get ready for the 7th grade state exam. So if you have a 7th grader, I would highly recommend that you get them a copy. You can grab a copy from Amazon. Now, to our exercise. Terms, like terms, and identifying like terms. These concepts are very, very important. If you want to be good or great at algebra, you must master these concepts. Now, let's talk about terms first. A term can be a numerical value. It could be an integer like -7 or +7. It could be a fraction, or it can be a decimal. Yes, now, a term can also be a variable or a combination of variables. For example, you have x or xy or abc. They are all terms, yes? A term can also be a combination of a numerical value and variables. For example, a term could be 2x or 2/3 y or 5ax. Yeah? A term can also be a combination of a variable or variables and exponents. For example, a term can be x squared. A term can be m cubed. A term can also be x squared y cubed. Yes? And lastly, a term can be a combination of a numerical value, variables, or a variable and exponents. For example, a term can be 2x to the 4th power, or 1/2 x squared y cubed, or 0.5a to the 2nd power. These are all examples of terms. Now, let's talk about like terms, or terms that are alike or similar. Yeah? Now, terms are alike, one, if they are numerical values or terms without variables. For example, 1 and 5 are alike because they are numerical values and they have no variables. 2/3 and 3/4 are also alike. Yes? Now, terms are also alike if they have the same variable or variables. For example, 1/2 x and 2/3 x are alike. Why? Because they have the same variable. So, terms are alike, one, if they have the same variable or variables. You have 4ay and 3ay. They are alike, why? Because they have the same variables. Now, note, when we are trying to determine whether these terms are alike or not, we're not paying attention to the values in front of the variables. Our focus will be on the variables. Once the terms have variables, they are alike if and only if the variable or variables are the same. Yes? And lastly, terms are alike if they have the same variable or variables and the same exponents. Okay? For example, here we have 4y squared and 5y squared. These terms are alike because they have the same variable and the same exponent. The variable is y for both, and the exponent is 2 for both of them. So they are alike. Also here, we have a raised to the third power, y raised to the fourth power, and the same here. We have a to the third power here, and y raised to the fourth power here. They are alike because the variables are the same, and the exponents are also the same. Remember again, we have no interest in the numerical value or the coefficients that are in front of the variables. Once the terms have variables and exponents, they are alike if and only if the variable or variables are the same and the exponents are the same as well. Get the idea? Now, let's identify like terms. So I'm going to put a few terms here and we're going to talk about if they're alike or not. Okay? I have 2a and 5a. These two terms are alike? Yes. Why? Because they have the same variable. Yes? The variable for this term is a. The variable for this term is a as well. So these two terms are, we're going to say, alike. You might be asking, well, why do I need to know how to identify like terms? Because in algebra, you can only add and subtract terms that are alike. So you must master this concept of identifying like terms. Okay? So it's not something that we can look over. We must master this concept once we're going to be doing algebra. Let's say we have 6y and 4x. What about these two? Alike or not alike? Oh, very good. Not alike. Why? Because the variable here is y and the variable here is x. They're not alike. Why? Because the variables are different. Now, let me see if I can get you here now. What if I give you two, let's say k and 2y? What about these two? Are they alike or not alike? They are not alike. Very good. Why? Again, because the variables are not the same. Now, even though they both have a 2 in front of the variables, what are we looking at? The variables will determine whether the terms are alike or not. The variables here are different. So therefore, they are not alike. All right. So far, so good. Let's keep it going. Let's keep it going. You must master this concept because when it's time to combine like terms or solve equations and inequalities, you must know how to identify like terms. When you're combining terms, you must know what are like terms because, again, the general rule in algebra is you can only add and subtract terms that are alike. So you must know how to identify like terms. Now, what if we have 2x squared and 4x? What about this one right here? Alike or not alike? Give it a try. Don't forget, you can look at the rules, use the rules or these facts to help you, determine whether these two terms are alike or not. What did you come up with? Alike or not alike? Let's see. Well, we know that they have variables, so because they are variables, we have to examine them. And there's also an exponent here, so we have to examine the exponent as well. Here we have x to the second power. Here we only have x. So the terms are not alike. Why? Because for them to be alike, what must happen? They must have the same variable or variables and the same exponent. So these two are not alike. Very good, very good. All right. I like how we are rolling here, and you guys are mastering this concept. Okay. What about these two? What about 4? Let's use the next number. Well, what about 12 and 8? Alike or not alike? What? Alike? No, not alike. Alike, yes? All right. Yes, these two are alike. Why? Because one, they are numerical values and they are without variables. They are numerical values. They are both integers. 1 and 2, they have no variables. Yes? So they are alike. All right. Rolling along, rolling along, rolling along. What if we have... What is it with me and the number 4? Let's say 7a, sorry, to the second power, and let's say 9a to the second power. What about these two? Or are they alike or not? These two are alike. Let's see why. Because they have the same variable and the same exponent. Here, the variable is a and the exponent is 2. Here, the variable is a and the exponent is 2. Therefore, our terms are alike because they have the same variable. Put a like right here. They have the same variable and the same exponent. All right, I'm going to put 1 on the board. I want you to try this one for me now. I'll put a negative 3x y. I'm going to put a 4yx. All right, I want you guys to give this one a try now. Give it a try. Tell me, like or not alike? These two terms are alike. Why? Let's see why. Well, here, the variables are x and y. What are your variables here? They are x and y as well. I just reversed them to see if you really got the concept. The rule says, or the fact says, if the variables are the same, no matter what order they are in, once the variables are the same, they are alike. So these two are alike. All right. What if we have 1/2 y and 2/3 y? Are they alike or not alike? Very good. They are alike. Why? Because they have the same variable. So because they are alike, we would be able to add these two terms or subtract these two terms. Yeah? All right. I hope you guys get the idea. It's just a matter of knowing the facts. Yeah? Knowing the different characteristics of like terms. Right? Just 3 simple facts. Learn these and you should be fine. Let's do our next one. Let's do one more for fun. Okay? Let's do 5a to the second and 5a as a 15a to the second y. Are these two alike or not alike? Okay, give it a shot. All right. What did you say? Like or not alike? Very good. They are not alike. Why? Because the variable here is a to the second power, or a squared. This term, however, has 2 variables. You have a to the second and you have y. So they are not alike because this one has a y, this one does not. This one has two variables. This term has only 1. Yes? Remember, if they're alike, they must have the same variable or variables and the same exponents. This one has, even though they both have a squared or a to the second power, this term doesn't have the y. Yes? Now, I really hope you guys enjoyed this video. Yes? I hope you'll find it useful. You must master these concepts, yeah? Practice as much as you want to. If you want to practice, you can always get my 7th grade math workbook. You can master 7th grade math, next generation learning standards. Tons of practice in that workbook. So again, I hope you enjoyed this video, and until next time, enjoy your math homework and remember to practice. See you.